right, hello AP Calcers. So I am going to go through the mini quiz from yesterday, 317. It seemed like this one tripped up some people along the way, so going to pay close attention to certain points. So the mini quiz was dy dx equals e to the y, with my initial condition being y of 1 is equal to 0. All right, so the first thing we're going to do is separate the variables. So I'm going to multiply by dx, and I'm going to divide by e to the y. All right, so I get 1 over e to the y dy equals dx. So I'm going to just rewrite this so that it's e to the negative y dy equals dx. And now that technically means like a 1 times dx. So I'm going to integrate both sides, aka find the antideriv. So the derivative of e to the negative y, it would have to be e to the negative y, and then you have to multiply by the derivative of your exponent. So if we're taking the antideriv, we've got to like undo that. So it's going to be e to the negative y, and then instead of multiplying by negative 1, we're going to divide by negative 1, which is negative e to the negative y. So that was a point that some people had lost that little negative sign there. All right, equals, and now the antiderivative of 1 is x plus c. All right, so at this point, I can plug in my initial condition, which is 1 comma 0, so e to the 0 equals 1 plus c. So anything raised to the 0 power is 1 times negative, so that's negative 1 equals 1 plus c. So subtract 1, we're going to get c equals negative 2. All right, so I plug that in, I get negative e to the negative y equals x minus 2. And so I want to solve for y, so I'm going to divide by negative 1. All right, so dividing by negative 1, and now I want to solve for y, so I have to get rid of the e. So I'm going to ln both sides. I combined those two. There we go. So the e and the ln are going to cancel, so it's going to be negative y equals ln of negative x plus 2. All right, and then last step, want to get the y by itself, so I'm going to divide everything by negative 1, or both sides by negative 1. And that is my final solution to my differential equation. All right.